Okay, let's start the class, right? Okay, so hi guys, welcome to NEET World Institute and NEET World YouTube channel. Yes, in last class we were discussing about the mechanical properties of fluids, right? So in this class also we will continue with this topic, that is mechanical properties of fluids, right? Yeah, 1 minute, let me take the file. Okay. Okay, let's go into the topic. Yeah, few more minutes, like 1 or 2 minutes. Okay, so it will get loaded. Okay, 2 minutes guys, it will get loaded and then we'll start with our topic wherever we left in the last class. Fine. I guess the board is clear, right? It's visible, I guess. Okay. Okay. Right. So in last class we were discussing up to the topic. Yes, this problem we were seeing, right? No, what is the pressure of on a swimmer 10 meter below the surface of the lake? So we have solved this problem right now, and the next topic is atmospheric pressure, right? So the pressure of a atmosphere at any point is equal to the weight of a column of a air of unit cross sectional area extending from that point to the top of the atmosphere. So if you take this, no, like I have taken a glass tube, okay, I have closed this glass tube now, it's in a vacuum now, okay. So now what I will do is I will reverse it. What happens here? So at this point, if I talk about this point or either this point, right, let me take point A, B, C. What will be the pressure we need to talk? So if you see here, like this point is vacuum, right? This point is vacuum. So point A and B, what will be the atmosphere? What will be the pressure we need to talk? At sea level, at a height of a mercury, no, mercury column is 76 centimeter. It's a fixed one. Okay, it's a fixed one. So above this column, it's vacuum. So we didn't allow any air to enter the glass tube. So what will be the thing? So pressure, gauge pressure will be equals to rho g h, and we know that in this point, no, the pressure will be 0. So this point, the pressure is rho g h. That's it. So pressure at A and B will be always equal. That is rho g h. Okay. So P and PB are at the same level. So but PA is atmospheric pressure. What about PB? Yes, it will also be same. Got it? Yeah. This is the thing. So P naught is rho g h and h is 76 into 10 power minus 2 and rho like density of the mercury is what 13.6 into 10 power 3 and gravity is 9.8. So approximately we will get 1.013 into 10 power 5 Pascal. Yes, we got the things no. So at exactly 76 centimeter only we should take the mercury column. Okay, this one of the question will be coming like what I should height I should take for the mercury column to be equal for the atmospheric pressure. So the height is 76 centimeter. Okay, so when the statement says the atmospheric pressure at a place of 76 centimeter of Hg, it means that atmospheric pressure at that place is equal to the pressure due to the mercury column of height 76 centimeter. Okay, this is the one of the important question. Okay, yeah, you can take a note of this. Done? Can we go for the next one? Okay. So next one is manometer. Okay. So if you see here in the manometer also, it's one of the application of the like the vertical column, right? So if you see here like P1 and P2, right, and P0, like 3 pressure we have taken. So when I talk about P1 and P2, no, like at the same height, no. So P1 will be equals to P2. So P1 will be equals to, P2 will be like, according to this I can take P2 will be equal, so P2 will be equals to P0 plus rho gh. Since P1 and P2 are equal, so P1 will be equals to h plus, P0 plus rho gh, where h is the height of the surface and rho is the density and g is the acceleration due to gravity, right? So we can take the reference of one pressure with respect to other pressure. Okay. So a manometer is a device used to measure the pressure of a gas or a liquid by comparing, right? Comparing to its known reference. We know the reference of P0 and by comparing these two first, these two, right? Now let me take P0 and P2. So we know that P2 will be equals to P0 plus rho gh. Since P1 and P2 are in the same height, P1 will be equals to P2, where P1 will be equals to P0 plus rho gh. Got it? Yes. So suppose if this differs, like the density also will be changed. Okay. Since they are in the same liquid, I can take it, I can compare it. Okay. So it typically operates on the principle of fluid column displacement, where the pressure difference causes a liquid like to raise or fall in the column. Okay, this is about the manometer. Got it? Yeah. So here is the question. A density of atmosphere at sea level is density of atmosphere. Okay, density they have given 1.29 kg per meter cube. Assume that it does not change with altitude. Then how high would the atmosphere extend? How high would the atmosphere extend? They are asking. So we know that atmospheric pressure P0 or PA will be equals to 10 power 5, right? 10 power 5, and they have given the density, that is 1.29. I'll take approximately 1.30. So they have given the rho as 1.30 kg per meter cube, and gravity I'll take it as 10. Okay, 10 I'll take it. Now P will be equals to rho gh. No, P will be equals to like P or P0 will be equals to rho gh. 10 power 5 will be equals to 1.30 into 10 into how much is height? I need to find that height. So height will be so 10 power 5 divided by 13. 10 power 5 divided by 13. I need to get the height. Okay. Yeah, the same thing here we have followed. 1.01 into 10 power 5 will be equals to 1.29 into 9.8 into h. So h will be, we will get 7989. So approximately it is 8 kilometer. So the sea level atmosphere pressure is not always 760 mm of Hg. A drop in Hg level by 10 mm or more is a sign of approaching the storm. Okay, this is one of the important question. You can take a note of this. Done. Can we go for the next question? No, next part. Note it down. Okay, done guys. So next question, at a depth of 1000 meter in an ocean, what is the absolute pressure? The first question is, what is absolute pressure? What is the gauge pressure? Okay, gauge pressure we know that, right? The delta P, that is nothing but P2 minus P naught or P minus P naught, right? Then find the force acting on the window, that is area 20 into 20 centimeter, like 20 centimeter into 20 centimeter of a submarine at this depth, the interior of which is maintained at sea level atmospheric pressure. Okay, so the density of a water is given as 1.03 into 10 power 3 kg per meter cube, and gravity we can take it as 10 meter per second square. So you have solid 2 minutes time to solve this question. Okay, yeah, first. Yeah guys, you have 1 more minute left out. One more minute. Done. Can we see the answers now? Okay, let's see the answers. So, the first one, so absolute pressure we need to find, right? Absolute pressure in the sense we need to find what is the P value, right? So, P will be equals to PA plus rho GH. So, when I talk about P minus PNO, I will get the gauge pressure. One is simple logic. I should take this PA to the left hand side, right? So, 10 power 5 into 10 power 5 plus 10 power 3 into 10 into 10 power 3. What I will get here, like I will do it only the calculation part you should do it, 10 power 3 into 10 power 3 again. Height, how much they have given? 1000 meter, no? So, 10 power 5 plus 3, 4 and this is 7, 10 power 5. I can take 10 power 5 commonly outside and this is 1 plus, how much is this one? 100, right now 100. So, approximately I am getting 101 into 10 power 5. So, 101 atm. So, we are getting no approximately, like we have taken approximately we are getting the value, okay. And when I talk about the gauge pressure, absolute pressure minus atmospheric pressure will give me gauge pressure. So, it is absolute pressure minus atmospheric pressure, right. So, I'll get the gauge pressure, got it. So, this is about the first question and the second question, right. So, what will be the third question? So, simple thing, we know the pressure and the area, what will be the force? So, pressure is equals to force by area, pressure is equals to force by area, right, no. So, yes, so F is equals to P by A or PA, yes, P into A, pressure is equals to force by area. What is force? So, pressure into area. So, pressure we know, right, no, the gauge pressure. And what about the area? Area we know, right, like they have given 10 centimeter into 10 centimeter, right. How much I should take? Yes, I should consider, see here, I mean 20 centimeter to 20 centimeter, not 10, okay, 20 centimeter to 20 centimeter into 20 centimeter. So, 20 into 10 power minus 2 into 20 into 10 power minus 2. So, 20 into 20, I mean 400 I will get, divide by how much is this? This is 10 power 4 denominator, 2 zeros and 2 zeros will get cancelled and 4 divided by 100 which gives me 0.04 area, right, 0.04 area we got. And when I talk about the gauge pressure, 103 into 10 power 5. So, approximately we will get 4 into 10 power 5 Newton. Got it? You can take a note of this and we can go for the next question. I mean next topic, okay. Completed? Okay, we'll go for the next one. Fine. Yeah, so the next application is hydraulic machine. Okay, so where we are using this hydraulic machine? Okay, so simple thing, first we'll understand what is Pascal's law. So whenever external pressure is applied on any part of a fluid, okay, which contain a vessel, it is transmitted undiminished and equally in all direction. So undiminished and equal in all direction. Suppose if I am applying some force and like they have some area, okay, I have applied some force on area, here also I will get some force, depends upon the area, but the pressure here and the here it will be equal. So P1 will be equals to P2. Got it? So what is P1? P1 is nothing but F1 by A1. What is P2? It is F2 by A2. So I can say that F1 by A1 will be equals to F2 by A2, where F1 is F2 into A1 by A2, or else F2 will be equals to F1 into A2 by A1. Okay, however we can rearrange the terms. So force F1 act over the area A1, so pressure will be F1 by A1. So similarly F2 and A2, the pressure will be F2 by A2. So similarly, like from the Pascal's law, no, like pressure 1 will be equals to pressure 2, as we have discussed here. So I can rearrange it and we can write however we want. So F1 will be equals to F2 times of A1 by A2, and F2 will be equals to F1 times of A2 by A1. So this is the Pascal's law, okay, and this is hydraulic machine application. Okay, you can take a note of this and we can go for the next one. Done? Okay. So here is the question. Two syringes of different cross section filled with water are connected with a tightly filled rubber tube filled with a water. Okay. A diameter of a smaller piston, diameter of the smaller piston they have given, not area. Okay. Diameter they have given as 1 centimeter and 3 centimeter respectively. Find the force exerted on the larger piston when the force of 10 Newton is smaller piston. Okay, so let me take F1 as a larger, like P1 pressure on larger piston, P2 pressure on smaller piston. What is the thing? P1 will be equals to P2, which is nothing but F1 by F2, sorry, F1 by A1 will be equals to F1 by A1 will be equals to F2 by A2, where I need to find F1. So it is F2 by A2 into A1. I have given the thing, and what is the thing they have given? Diameter D1 will be equals to, so D1 will be equals to 3 centimeter, right? No, 3 centimeter. D2 will be equals to 1 centimeter. Convert it into meter. Okay, convert to meter. I have given the hint also. Like if the smaller piston is pushed in through 6 centimeter, how much the larger piston move out? That also I need to find it. Okay, so first question, you have solid 1 minute time. Get the answer first, we will discuss the answer. Completed? Okay. So if you see the answer, you will get it as 90 Newton. 90 Newton. How it is means 1 centimeter for the smaller piston, right? No diameter, and larger piston 3 centimeter. What is the formula we know? Pi r square, right? No, r diameter they have given, right? Diameter in the sense r will be equals to d by 2. So pi into d by 2 the whole square, I will get it as d square by 4. So now I can use as it is, no? Yes, I can use as it is. No need to calculate for pi. When I use the ratios, the pi and pi will get cancelled, and 4 and 4 also will get cancelled off. Okay. So 10, pi and pi will get cancelled, 3 square is 9 and 4 and 4 will get cancelled. So 10 into 9 is 90 Newton. So when they have given 10 Newton on smaller piston, 90 Newton will be exerted on the larger piston. Okay. That's the thing. Got it? Yeah. So the next question. If a smaller piston is pushed in through 6 centimeter, how much does the larger piston move out? Got it, na? So since the volume of a water displaced in one piston will be equals to volume displaced on other piston. So volume is nothing but area into length or height we can take. So area of a smaller piston, height of a smaller piston will be equals to area of a larger piston, height of a larger piston, right? So height of a larger piston, I need to get it right. Right now, smaller piston they have given us 6 centimeter. I can convert this as 6 into 10 power minus 2 meter. Got it? Now, so d is like diameter of small piston divided by diameter of larger piston, the whole square, into height of the smaller piston. So how much we will get? It is 0.67 centimeter, or if we want in meter, we can convert it into meter also. So this is about the second part of the equation. Got it? Okay guys, so with this we'll end up this today's session of the fluid part, and we'll continue with the next class. Okay, I hope you have got some idea about how to proceed with these questions, right? Yeah, so thank you guys, we'll meet in the next class.